In part 2, we will add this attack cone that the player must be within in order to activate the sneak attack. We will also solve the problem of being able to attack multiple characters. We can use our interface to solve the first issue of being able to attack again by saying sneak attack over. We can just have a function. Compile that. We can add the same interface to our sneak character, the player character. BPI warp, and we can just we can just do the sneak attack over function, and on that we'll just say is sneak attacking. We can set that to false. Then in the victim, at the end of this montage here, so when it's completed, we can get the attacker and say sneak attack over using the interface. Maybe just give a little delay. And that should reset it. We play, crouch, we can sneak attack this character. And then we should be able to sneak attack this character. As you can see, we are rotating correctly to the correct location using the motion warping. So that's those two issues. That's that first issue solved. In order to solve the next problems, we're going to have to make some references. So if we go to our trace for victim, the first thing we will do is we will check if the hit actor implements our interface. So this will tell us whether it's a victim or not. So we'll check for BPI warp. We'll branch on this, and then we will, if it is true, store a reference to the hit actor as a reference to the victim. We can then use this in further functions. So if it is true, we will set it as the hit actor. We will also store a reference to the hit result, because this will contain information on things like the trace distance, which we will need in the future. If it does not implement the interface, we can just clear the victim reference. And if it does not hit anything, we can clear the victim reference on each trace as well. For the time being, we can plug it back into the end function. Now if we go back to our trigger attack on victim, we can use this new victim reference we've got. So we can check to see that it's valid. We can then use the victim reference to trigger the attack and remove the victim that we were sending through. And then just refresh the original function. We want to restrict the angle at which the player can attack the victim. So we want it to be within this cone, which is a 15-degree cone. So the way that we're going to work out whether the player is in the cone or not is by using a dot product. We want to work out the angle between the back vector of the enemy and the angle between the enemy and the player. And that angle, which we could call theta, needs to fall within 15 degrees. So it is within this cone that we have drawn, and only then can the player attack the enemy. The way that we're going to do that is with dot products. So in a dot product, if two vectors are pointing in the same direction, the value is 1. If they are perpendicular, it is 0. And if they are facing opposite directions, it is a -1. And the result always comes out as a scalar, which we can then turn into degrees and use. Returning to our sneak character, we can now start adding more conditions to the can sneak attack. So we want to add a way of ensuring that the angle is valid. So I've created a sneak attack angle function, and I've just added a draw debug cone. So the cone's location is the victim's origin. We then want the back vector, so multiply it by -1, the forward vector. We've got a length and an angle width. So I'm going to promote these just to variables. So this will be our trace distance. And the angle width will be the angle at which he must be within his approach. So this will be the angle width, the attack angle width. This trace distance we can perhaps use here now. So instead of this, in the trace for victim, let's just make sure these are all similar. So can sneak attack. So we have this. We can just collapse this, collapse these nodes to make it clearer. This is the debug cone. So first we'll draw the cone. Now we need to do the dot products. So what we need is the victim, because we want the back vector. Get victim, get actor, forward vector, and we can multiply that by -1, and that will give us the back vector. We then want to dot product this with the vector that is the direction from the victim to the player. So again, we want the victim reference. We want to say the get unit direction, so we need the actor location. We need our location of the sneak character. And we can do a unit direction. So this will give us the two vectors. Now we want to do a dot product on these. Dot product, and this will give us a scalar value. Now to turn the scalar value into a degrees, we can use the arc cosine. So that's a cos, and we take it in degrees. That will be the best for us. We can then check to see if our degrees are less than or equal to the attack angle width. And if that is true, we can then do a return node. In fact, we don't need to check for this, do we? We can just return whether we're in the correct angle or not. So we can compile that, make this a pure function, go back to our sneak attack. We can add another condition and sneak angle valid. Put that in there. We can add a print string so we can print out the angle, and then we can check to see if that works. So back in our editor, we crouch and we approach from this angle here. So our angle is 21 degrees. That's not enough. If we come here, now our angle is okay, we can attack. Similar, if we try to attack this character, enemy, our angle is not in the cone. We're still not in the cone. Still not in the cone. And now we are, so we can attack. The next thing we want to add is a distance range in which the player can activate the attack. So say for instance when they're between 350 to 400 units away, we give them the chance to activate. So we could create a function, distance check for sneak attack. We've already have a reference to the hit result, so we can get that, we can split it, and this gives us the distance of the trace that is hit. We can then compare that to a range, so we can create another variable, so distance range for attack. We can set that as a float range, compile that, so we could say it's between 400, and you have to set the maximum before you can change the minimum if it's not working. So now we can check to see whether this is in range. And the minimum, the maximum we can get from our new variable. So we can split that again, and that gives us the minimum and the maximum. So the lower bound is the minimum, the upper bound is the maximum. And then we can return this to tell us whether it's in the range or not, and make that a pure function, and go back to here, and we can add another Boolean check. So now all of these would have to be true. Instead of using debug keys, I'm going to add some input actions. So we can just maybe duplicate one of these, say input action for crouch, and duplicate and say input action for sneak attack. You can also just go here, input, and pick an input action. And these are stored in our third person blueprint input. So go back here, now we get the IMC default. We can open that and add some of these mappings. So this one we could add for crouch, set that as C. Add another one for our sneak attack, and add that as X. Back in our sneak character, we can remove this and change it to IA crouch. And on started. To take advantage of the range that we've set for the attack, we should show a widget on the screen, and while that widget is visible when the conditions are met, the player can press X to activate the sneak attack. So I've created a simple widget just with a canvas panel and a text block. And if we go back to our sneak character, we should perhaps change some of these. So instead of trigger attack on victim, we should maybe rename this to be, so to check attack conditions met. And then back in the trace, so every time it traces, it should run a check on whether the attack conditions are met or not. If they are met, so can sneak attack is true, we should show that widget on the screen. So if it's true, we should say create widget. That's the widget. We've got the WPP sneak attack. And then we can just maybe keep a reference to this. Sneak attack widget reference. And we can say add to viewport. Now we probably only want to do this if we do not have a reference to it. So we can do a validated, so we say true here, and if it's not valid, then we add it to the screen. If can sneak attack is false, we want to get our sneak attack widget, convert that to a validated get, and if that's true, we want to remove it. And we want to set the widget reference to a null pointer. If the victim is not valid, we also want to remove the widget from being shown. So we just test that out very quickly. So we press C. When we come up into the correct angle, we can press it to attack. If we get too close, we can't do it. And again, if we're not in the cone, we won't get the option to do it. So to activate the attack, we want to get our IA sneak attack. We need to have a condition to check, so we can only attack if the widget is showing, so we could get a reference to our widget, make that convert to validated get, and if it is showing, then we can trigger this function here. We can set that to true. We then want to remove the widget, so we want to say sneak attack widget, remove from parent, and we want to set this, and we want to clear it. So if we compile and go back to our editor, and let's test it. So I press C, I get into the correct angle. If I press X now, then I will go and attack. If I come to this guy, I need to find the right angle. So now I can press X, and I can sneak attack. So I've increased the trace distance and changed the range so we can get a slightly better effect. And obviously you would have to tweak these numbers so that it fits in with the animations that you've created. So now our character has defined conditions in which he can attack the enemy, particularly that he has to be a certain distance and within this cone, and then he will trigger the motion warping attack. So that should be enough for part 2. I think in part 3 we will look at how we can use this camera animation sequence to add some extra effects.